All right, welcome to our lesson of Newton's law of cooling. So first, what we want to do for really explaining the law and writing a function using the law to determine the number of hours since the victim died is use this formula. So as you can see, it's the temperature of the room plus, in parentheses, T1 minus T room times e to the negative kt. So this T room is the temperature of your environment that you're in. The T1 is the recorded temperature that you're using. The T room again is obviously the same thing. E is the exponential number. K is going to be your constant for your rate of decay. And then T is going to be the time since death. And all this is going to be set equal to temperature as a function of time. Okay, so for this particular murder, we found the body at 5:41 a.m.
Yes.
And then at 6:41, so at 5:41 we did a measurement and the body was 78 degrees Fahrenheit, and then at 6:41 we did a measurement and the body was 76.6 degrees Fahrenheit. And so when you put each of those in for their own variables, you have the T of T, which is 76.6 degrees Fahrenheit, which is what we measured after an hour. And we found that the thermostat of the room was reading 71.0 degrees Fahrenheit. So the T room is going to be 71 degrees. And then so the initial temperature that we recorded, like I said, was 78.0 degrees. And then you just plug in the same temperature of the room, and then times E raised to the negative, because this is a decay value, so it's negative K, and then T was just 1 hour, so you can just kind of leave it blank. And so from there, you can easily solve for K. You can start off by subtracting 71 from each side of the equation to get 5.6 equals, and then 78 minus 71 degrees is 7 times E to the negative K. And then, so using the, so first dividing by 7 from each side, you end up with 0.8 equals E to the negative K. And by using properties of logs, you can find out that ln of 0. The natural log, because it's going to be a log base E of 0.8, is equal to negative K. And when you take the natural log of 0.8, the resulting value is negative
0.2231,
which equals negative K, and divide each side by negative 1. The K, which is the decay rate, equals 0.2231.
0.2231 is the end result of K.
So the next step in solving this is finding out how long ago the person died. So this time in your Newton's law of cooling equation, you solve for T. And so right now, how we just solved for K, we have K equals 0.2231, and our new T naught, our T1, is going to be 98.6 degrees, because we know that's the temperature of the body when it died. The
Just before death.
The temperature of the room is still going to be 71 degrees. And
These measurements are all in Fahrenheit?
Yeah.
Yes.
And what we're solving for is T. So it's going to end up looking like... So for our 78 degrees is going to be our temperature as a function of time, because that is the temperature we measured the body to be at 541. And so that's going to equal 71, which is the temperature of the room, plus the T initial, which is 98.6, minus the temperature of the room, which is still 71, and then times E raised to the... So we know that K is 0.2231, so it's a negative 0.2231 T.
I'm gonna go get some cereal.
Okay. And so when we have this written out, obviously the first thing you're going to want to do is try to simplify the equation as much as possible. So 78 minus 71 right here, you're going to have 7 equals 98.6 minus 71, which is 27.6, E raised to the negative 0.2231 T. And then dividing each side by 27.6, the resultant is 0.2536 equals E raised to the negative 0.2231 T. And so using properties of logarithms, you can solve for the natural log of 0.2536 equals negative 0.2231 T. And, dude, can you not eat chips next to this? And so the natural log of 0.2536 is negative 1.3720, which equals negative 0.2231 T. And so dividing each side by negative 0.2231, you get T equals 6.15 hours since death. And we found the body at 5:41 a.m. And so taking away 6.15 hours, you get that the body was murdered around...
Tim Reinhardt.
Dude, come on.
Wait, is that bad?
That's not even right. And so you get that the body was murdered around 11:10 p.m. And who else was at the chemistry lab between 10 p.m. and midnight except for Jeffrey? So he is the murderer, because when we solved Newton's law of cooling, we found that the body was murdered at 11:10 p.m. and he was there from 10 to 11. So yeah, we solved the case.
Yay.